Although many of today's motorists, your service customers, take engine performance for granted, Ford doesn't. Whether in spring's awakening or summer's wide open fun, whether in autumn's colorful display or winter's vigorous challenges, Ford is responsive to motorists' demands for top engine performance season after season, year after year. Ford Quality Service assures that owners' demands are met at all times. That's your job. One area that sometimes needs service is the cylinder head. Proper cylinder head service assures smooth engine performance, trouble-free operation, reliable starts at all weather, and greater fuel efficiency. More important, good cylinder head service increases your customer's satisfaction with his vehicle and loyalty to Ford product and your dealership's service department. Make no mistake, cylinder head service is far more than just a valve job. Cylinder head service is total in its approach, involving repair or reworking of the cylinder head and its related components. That's why, upon completion of this video disc program, all technicians will be able to meet these objectives: disassemble cylinder heads, service cylinder heads and the related components, clean cylinder heads and the related components, reassemble cylinder heads, and use the proper tools, equipment, and measuring devices for cylinder head service. Here are some symptoms that may lead to cylinder head service: loss of compression, rough idle, excessive oil and fuel consumption, loss of coolant, and unusual engine noise. Disassembly and certain cylinder head procedures are discussed on side 1 of this video disc. Procedures relating to camshaft and camshaft bearings, valve seat and valve face grinding, and cylinder head cleaning are discussed on side 2. Service procedures are covered in greater detail in your appropriate shop manuals. Before moving on to cylinder head service, let's learn exactly what makes up a cylinder head. The cylinder head is one of the most complex components of the automobile engine. Cylinder heads are normally made from cast iron or aluminum. The head forms a top for the cylinders. In the 2.3-liter overhead cam cylinder head, the components are the camshaft support housing towers, which are machined into the cylinder head, the camshaft with its journals and lobes, cam followers, valve springs with retainers and keepers, valve guides, intake and exhaust valves, valve seats, intake and exhaust ports, and coolant passages. In this 2.3-liter high-swirl combustion head, the camshaft is mounted in the block. Push rods are used to transfer mechanical movement to the rocker arms. In the 1.9-liter cylinder head, there is no need for push rods. The camshaft is supported in the head by 5 bearing surfaces. To absorb camshaft thrust and maintain proper end play, a thrust plate is installed over the cam at the front end of the cylinder head. The hydraulic tappets are installed in the head between the camshaft and the valve rocker arms, and they operate the rocker arms directly. To reinforce the learning process, you will have a number of opportunities to test yourself by means of multiple choice progress review questions or to review the material if necessary. The cylinder head can be removed from the block or from under the hood. Consult your shop manuals for complete step-by-step instructions. Once removed, the head and its components are ready for any necessary service. First, let's consider some preliminary cleaning and inspection procedures. When you remove a cylinder head, the gasket may loosen cleanly, or you may find part of the gasket stuck to the head and block. If so, scrape off any gasket residue. Be very careful not to damage the head surface. Next, remove any deposits from the combustion chamber and valve heads. Then, clean the gasket mating surface of the intake and exhaust manifolds. Now, inspect the head carefully for any burrs, nicks, dents, or cracks. Important, if a cylinder head is cracked, it must be replaced. Next, check for warpage on the head gasket surface by using a precision straight edge and a feeler gauge of the correct thickness. A common limit for warpage is 1/1000th of an inch or 0.025 millimeters within a 12-inch area. If warpage exceeds the common limit, the cylinder head must be resurfaced. Otherwise, there won't be proper gasket sealing between the head and the block. Check aluminum cylinder heads for any corrosion damage around the coolant and oil passages. Then, inspect the aluminum head thoroughly for cracks and any excessively burned areas around the valve seats. If during inspection you notice a damaged thread area, you can restore the thread with a helicoil thread repair kit or equivalent. For example, if you have a damaged thread, drill out the threaded area with a proper sized drill from the helicoil thread repair kit. Next, tap the area to be restored. Use aluminum cutting oil to lubricate the tap. And then install a proper helicoil insert by threading it into the tapped bore. The damaged thread area has now been restored and a new stud can be put in. Now here's a chance to test yourself on cylinder head service before moving on. Here are some multiple choice questions. If you answer them correctly, great. If not, you'll have a chance to review the material. Think carefully before you answer.
You bet your aluminum you got that one right. Great going. You really had a feel for that one. Terrific. You knew where the camshaft belonged. Right on the button. Keep up the good work.
If you need more details on what we've covered so far, consult the appropriate shop manual. And now let's move on to cover another aspect of cylinder head service: cam followers and rocker arms. Cam followers on an overhead cam cylinder head are used to transfer the mechanical energy from the camshaft to the valves. By using a different method, rocker arms on a 2.3-liter HSC engine also transfer the mechanical energy from the camshaft to the valve. Now let's consider cam follower and rocker arm removal. First, rotate the camshaft so that the base circle of the cam is facing one of the cam followers. Use a valve spring compressor and compress the valve spring. Then lift the cam follower off the lash adjuster and valve stem and slide it out. Inspect the cam follower carefully for any scruffing, excessive wear, cracks, nicks, and burrs. Inspect the pad end where the cam follower comes in contact with the valve stem. If the pad is grooved, replace the cam follower. Do not try to true this surface by grinding. Inspection of the cam follower, especially the pad, is a very important part of cylinder head service, particularly if there's a valve problem. Replace the cam follower if necessary. Otherwise, proper valve action won't occur. Now, lift out the lash adjuster. Place the cam follower, lash adjuster, and all other such cylinder head components on a numbered storage rack to ensure proper reassembly. Now let's consider a fulcrum-mounted rocker arm on a 2.3-liter HSC cylinder head. The rocker arms were loosened and the push rods removed before the cylinder head was removed from the engine. Remove the rocker arm fulcrum attaching bolt. Then remove the fulcrum and the rocker arm. Check the fulcrum seat for excessive wear, cracks, nicks, or burrs, and inspect the rocker arm fulcrum bolt for damaged threads. Again, careful inspection of the entire rocker arm assembly is very important. If there is excessive wear, the rocker arm should be replaced. Now let's consider a fulcrum-mounted rocker arm on the 1.9-liter cylinder head. Remember, it's operated by hydraulic tappets between the camshaft and the rocker arm. Remove the attaching bolt. Then remove the fulcrum, the rocker arm, the tappet guide retainer, tappet guide, and the hydraulic tappet. While on rocker arms, let's consider another cylinder head. This is the head from a 4.9-liter light truck engine. Here we're concerned only with removal and replacement of rocker arm studs. The procedures also apply to some 5-liter and 5.8-liter engines. Inspect the rocker arm studs for stripped or otherwise damaged threads. If there is wear or damage, the stud must be replaced. To remove the damaged stud, use a rocker arm stud remover. Place the bearing over the stud and seat it on the flat boss of the head. Thread the remover screw onto the stud and tighten. Place the counterboard end of the outer sleeve over the remover screw. Thread it down until it contacts the top of the bearing. Hold the remover screw with a wrench while turning the outer sleeve with another wrench to remove the stud. To replace rocker arm studs, coat the end of the new stud with polyethylene grease or its equivalent. Then align the stud with the stud bore. Put the stud replacer tool over the new stud. Then tap the stud replacer with a hammer. When the stud contacts the stud boss, it's installed. If a loose rocker arm stud is being replaced, the stud bore will have to be reamed for a new oversized stud. For complete details, consult your light truck shop manual. Now, here's another opportunity to test yourself or review the material on cam followers and rocker arms. Think carefully before you answer.
No fooling you on that one. A transfer of mechanical energy is what happens. Keep it up. Fulcrum was the correct answer. Congratulations. Don't ever grind your rocker arm pad. I'm glad you knew that. Right. Always remove the camshaft carefully. You don't want to damage those journals and lobes. Bullseye. You'll have to replace or ream out the valve guide. You know it. Those intake valves have a larger diameter. Right on the button. Keep up the good work. You're doing great. Congratulations. That's absolutely correct. Keep it up. Bullseye. That's the right answer. Great going. Now don't let up. Pat yourself on the back. You're right again. Couldn't fool you, could we?
That's correct.
Congratulations. That's really using your head. You've done your homework. Now don't let up. Hang in there. You're doing just fine.
Now let's move on to cover another aspect of cylinder head service, the camshaft. Camshafts are manufactured for long service life. Journals on the camshaft allow it to rotate smoothly within the bearings. The cam bearings are mounted in the cam towers. Egg-shaped lobes on the camshaft raise and lower the cam followers. Their design determines when and how far the valve will open and how long it will remain open. Now let's cover the procedures for camshaft removal. First, remove the seal with a front cover seal remover or equivalent. Next, remove the 2 screws in the camshaft rear retainer plate and remove the retainer. As you remove the camshaft, be careful not to damage the journals and lobes. To remove the camshaft from the 1.9 liter cylinder head, first remove the camshaft sprocket and key. Then remove the camshaft thrust plate. And remove the camshaft from the back of the head. Use extra care to prevent damage. Finally, remove the seal. For more detailed information on camshaft removal, consult your shop manuals. Servicing the camshaft and camshaft bearings is covered in a separate section on side 2 of this video disc. Now let's consider another aspect of the cylinder head service, Valvetrain components. These include the intake and exhaust valves, the valve keepers, the valve spring retainers, the valve springs, the valve oil seals, the valve guides, and the valve seats. Valves are made of special high-strength steel that is extremely heat resistant. The intake valve is larger in diameter than the exhaust valve. That increase in diameter helps air and fuel flow into the combustion chamber. That's important because air and fuel move more slowly into the combustion chamber than exhaust gases under pressure move out of it. Now let's look at the Valvetrain components in relationship to each other. A valve keeper groove is machined into the valve stem. The groove is designed to hold the valve keeper. A split steel lock with grooves to match the keeper grooves on the valve stem. Valve spring pressure pushes the valve spring retainer over the keepers to hold the valve and spring assembly in the head. The valve spring closes the valve when it's not operating. It's ground flat at each end to seat squarely and distribute pressure evenly, so that the Valvetrain follows the cam lobe profile for controlled opening and closing of the valve. The valve oil seal controls the oil supply to the valve guide area. The guide, either machined in the head or pressed in, keeps the valve in correct alignment with the valve seat, which is either an integral part of the head or an alloy steel insert. The valve seat is that area where the valve face makes contact when the valve is closed. When there are no valve problems, Valvetrain operation looks like this, smooth and trouble-free. Notice the valve overlap, the period when the intake and exhaust valves are open at the same time. But when a valve problem is indicated, valve repair or replacement may be necessary, and we have to determine the extent of such repair or replacement. First, let's consider valve removal. To remove a valve from the 2.3 liter OHC head, first compress the valve spring with a valve spring compressor. Then use a pencil magnet to remove the valve keepers. Next, remove the valve spring retainer and the valve spring. follow the same procedure for the remaining valves. If upon inspection you find the tip of the valve is mushroomed, chamfer or dress the top corner with an appropriate file. Remove the remaining valves in the same manner. Then remove and discard all the oil seals. Keep everything in the order in which it was removed, so it can be reinstalled in its original location if serviceable. The procedure for removing the valves on a 2.3-liter HSC cylinder head is essentially the same. Compress the valve spring, remove the valve keepers, and release the spring. You can now remove the spring retainer, the valve spring, the valve, and the valve stem seal. Discard the seal. Remove the remaining valves in the same manner. Again, the steps to remove the valves from the 1.9-liter cylinder head are essentially the same. Now let's consider some inspection, cleaning, and measuring requirements for Valvetrain components. They're very important. Remove all carbon deposits from the valves with a wire wheel. Afterwards, wash them in cleaning solvent and blow dry with compressed air. Inspect the valves for burned areas, erosion, warpage, cracks, and other damage. Measure 3 areas of the stem for wear. If wear is over 1/1000th of an inch or 0.025 millimeters, the valve must be replaced. Clean the valve guides with solvent to remove any dirt, grease, or other deposits. Insert a valve stem into its guide. If there is tipping, there is valve guide wear. Check the stem to guide clearance of each valve with a valve stem clearance tool. Use a flat end indicator point. The tool should be fully seated on the valve stem. Tighten the set screw firmly and let the valve drop away from its seat until the tool contacts the upper surface of the valve guide. Position the tool with its flat tip against the center portion of the tool's spherical section at approximately 90 degrees to the valve stem axis. Move the tool back and forth in line with the indicator stem and take a reading on the dial indicator without removing the tool from the upper surface of the valve. Divide the reading by 2, the tool's division factor. The resultant measurement is the valve stem clearance. That inspection and measurement must be made to assure valve seating accuracy, fuel efficiency, easy starts, smooth throttle response. In short, maximum engine performance. If stem to valve guide clearance is not within specifications, the valve guides may have to be replaced or repaired by reaming. Inspect the valve springs for signs of rust, nicks, or cracks. If they're evident, discard the spring. Weak valve springs cause poor engine performance, so check the springs for proper tension or pressure at the specified spring lengths in pounds per square inch. If the pressure of any spring is lower than the service limit, replace it. Check each spring for squareness using a steel square on a flat surface. Slide the spring up to the square. Then rotate the spring slowly. Observe the space between the top coil of the spring and the square. If the spring does not meet specifications for out-of-square limits, it must be replaced. Also, visually inspect the valve spring retainers and keepers for wear or damage. To determine if valve keepers are worn, compare them with new ones. Discard any damaged parts. Now, here's a chance to test yourself on what you've learned about camshafts and Valvetrain components. Or, if necessary, an opportunity to review the material. Think carefully before you answer. To summarize what we've covered so far, we've considered cylinder head components, cam follower and rocker arm removal, camshaft removal, valve removal, and some preliminary cleaning, inspection, and measurement of components. On side 2 of this video disc, we'll cover specific service procedures pertaining to camshafts, camshaft bearings, valve face and valve seat grinding, valve guide reaming, and cylinder head cleaning. And again, you'll have a chance to test yourself as you move along.